So let's talk about some identities. An identity is a statement that is true for all values of the input on which they're defined. So here's some identities that we already know. So we already know that cosecant is equivalent to 1 over sine, and that secant is equivalent to 1 over cosine, so on and so forth. So what we can do is we can use these concepts to figure out the value of the 4 remaining trig functions. So for example, if they told me that sine is negative 5 over 13 and cosine is 12 over 13, we can find the value of the 4 remaining trig functions. So when I do problems like this, the first thing that I always do is I write out all, this should be t, not theta, all of the remaining trig functions. And make sure when you're writing this, I always notice a lot of students just want to write sine equals. Make sure you write the sine of theta or the sine of whatever your angle is labeled as. So sine, cosine, which I know is 12 over 13, tangent, don't know yet, cosecant, I don't know yet, secant, and cotangent. So I always do this for myself so I never forget to find one, and then it also just helps keep my work organized. So we know that tangent is sine divided by cosine, so that's going to be negative 5 over 13 divided by 12 over 13, which gives me negative 5 over 13 times 13 over 12. Those guys cancel, so I'm left with negative 5 over 12. We know that cosecant is the reciprocal of sine, so it's going to be negative 13 over 5. Secant is the reciprocal of the cosine function, so that's going to be 13 over 12. And then cotangent is a reciprocal of the tangent function, so negative 12 over 5. I'm going to teach you another identity that you can use to solve these types of problems. So we're going to learn this, what's called the Pythagorean identity. And a lot of you guys at some point have heard of the Pythagorean theorem. We actually talked about it in our last section, and that's what we just were using. X squared plus y squared equals r squared. Oops. It's normally like legs a squared plus b squared equals c squared is usually the variables that are used. And so what we can do is we can take this and actually create the Pythagorean identity. So that Pythagorean identity, if we start out with that, so x squared plus y squared equals r squared. So if we divide everything by r squared, which is totally legal as long as we do one thing to one side and the same thing to the other side, it's a legal math move. So that gives me 1 on this side. Well, I can rewrite x squared over r squared as x over r squared. I can rewrite this as y over r quantity squared. You don't need to know this proof, but I just want to show you guys where this Pythagorean identity is derived from. So x over r we know is cosine, so cosine squared theta. Y over r is sine, so that's going to be sine squared theta, and that equals 1. So this is the new Pythagorean identity of 1, or of sine squared plus cosine squared equals 1, or cosine squared plus sine squared equals 1. So these are right here. So we've got several of them for you guys to know, and these do need to be memorized. So sine squared plus cosine squared equals 1, tangent squared plus theta plus 1 equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. If you'd like to see the proof for this, you can easily see so in your book. I'm not going to go through it now just because I know we don't have a ton of time to do that. I want to try to focus on what you need to know and how to use these. But again, if you do want to see the proof of where they're derived from, like I showed the sine squared plus cosine squared equals 1, you can totally look at your book for that. So now let's do that same problem, but let's actually find the value of all 5 of these using that Pythagorean identity. So now instead of using those x over r's, y over r's, and all of that, we can do this. So again, we'd start out the same way, sine squared, or sine, cosine, tangent, and then we've got cosecant, secant, cotangent, and we're in quadrant 2. which means that my cosine and tangents and secants and cotangents are negative. So now what we could do is, instead of doing the x squared plus y squared equals r squared and doing things in terms of x and y's and r's, we know that sine is 3 over 7, and we know this new Pythagorean identity. Sine squared plus cosine squared equals 1. So sine squared is 3 over 7 squared. Cosine squared is, we don't know. So I get 9 over 49 plus cosine squared theta equals 1. I'm going to subtract, the 9 over 49 from both sides. So that leaves me with cosine squared theta equals 1 minus 9 over 49. So remember, when we're subtracting fractions, you need to have a common denominator. So I'm going to multiply 1 by 49 over 49. So that gives me 49 over 49 minus 9 over 49, which gives me 40 over 49. So when you subtract or add fractions, the denominator stays the same, and you just add or subtract that numerator. And then this is again the cosine squared. So what I need to do is I need to square root this. So when I square root this, I'm going to do it up here. So cosine is the square root of 40 over 49. So that gives me, I can rewrite this as the square root of 40 over the square root of 49. Well, the square root of 40, and again, it's always plus or minus when you're square rooting, but we already know that cosine is going to end up being negative, so I'm just going to stick with that negative. So that's going to give me negative 2 root 10 all over 7, which is what we got on the last page. And I'll leave it to you to finish the rest of these up using those other identities to figure out what tangent is, and then you can then use the reciprocals for the rest of this stuff. So these identities are really helpful in helping us solve problems that are complicated, like these two. And also, if we have an angle that we maybe don't have an exact value of from that unit circle, like 50 degrees, but we can still figure out what the exact value of this expression is without using a calculator. So here, notice that both of these angles are the exact same. We know that identity, that sine squared theta plus cosine squared theta equals 1. And so we can go from there and say, oh, well, our theta is both 50, so sine squared of 50 plus cosine squared of 50 equals 1 then. Looking over here, you could go through and put in pi over 4, all of that grossness, but what I would do is just look here. So we've got secant of pi over 4, so that's the same thing as, we can use that identity, 1 over cosine of root 2 of pi over 4. And then cosecant is the same thing as the sine of pi over 4. So by doing that now, again, we don't have these exact values in our table or in our unit circle chart, but we do have those exact values for cosine and sine. So I'm going to change these so that I have them in terms of cosine and sine. So when I do that, dividing by a fraction is the same thing as multiplying by the reciprocal. So we'll multiply by sine of pi over 4 over 1. And that's going to give me the sine of pi over 4 all over the cosine of pi over 4. Well, the sine of pi over 4 is root 2 over 2. The cosine of pi over 4 is root 2 over 2, which then when you divide those, you're just going to get 1.